And our next speaker is Mr. Reza Labbaf from Danish area from Iran. And today he will be presenting on challenges with external cathodic protection of above ground storage, tanks and this solution for soil side corrosion by use of VCI technology. Over to you, sir. Reza, sir?
Yes,
is it
hello,
audible?
hello everybody.
Yes, sir.
You hear me?
Yes, sir.
Okay, good morning, good afternoon, good evening. I am Reza Labbaf from Iran, from Danish area Co. My presentation is about challenges with external cathodic protection of above ground storage tanks, and I am going to describe about how VCI technology can be utilized as a solution for soil side corrosion. Please, next slide. Okay. I am a corrosion engineer and cathodic protection engineer with more than 17 years of experience in oil and gas industry. Above ground storage tanks, or at-grade storage tanks, or ASTs in brief, are metallic structures usually from carbon steel or low alloy steel in a cylindrical shape, which are constructed on the ground to store water or hydrocarbon products. Like other metallic structures in contact with soil or liquid, above ground storage tanks are subject to corrosion. The internal surface, please click. The internal surface of the tank, which is in contact with the stored liquid, can result in internal corrosion. Please click on the page. Okay. Yes, this is internal corrosion. The external surface of the tank shell, which is in contact with the air, may result in atmospheric corrosion, as you see in the picture. And the external surface of the tank bottom, which is in contact with the ground or foundation, results in a type of corrosion that we call it soil side corrosion. And this is the most challenging because you do not have access to the underside of the tank. And when the tank is installed, it is more difficult to monitor and control the physical condition of the external surface of the tank bottom. Next slide, please. Soil side corrosion of the bottom plates of above ground crude oil storage tanks is a chronic problem in the oil and gas industry, especially in the coastal tank farms. The traditional method to combat this problem is the application of coating plus cathodic protection. External coating of the bottom plates is a partial protection method because welding of the bottom plates removes the coating along the weld lines and its perimeter. So you don't have the full protection by coating application. On the other side, there are lots of reports that CP is partially or completely failed to protect the soil side of the tank bottom. Next slide, please. Because CP cannot reach all areas of the bottom plate. Next slide, please. All areas of the bottom plate, and sometimes the tank foundation material has been too corrosive to overcome pitting corrosion by cathodic protection. So you have localized corrosion or pitting in this situation. According to API, American Petroleum Institute's recommended practice 651, tank pads and their effects on corrosion depends on the type of the corrosion underside of the bottom plates. Tank pads includes asphalt continuous layers, In some cases, you have tanks constructed on concrete slab. In some cases, you have clean sand layer as the last layer in contact with the tank bottom plate, or sometimes tank constructors use oily sand layer as the last layer in contact with the tank bottom. It depends on the mechanical aspects and the civil engineers, but in regards to the cathodic protection, there are challenges and there are benefits and advantages and disadvantages in each case. Even after several years of construction and operation of above ground storage tanks, the benefits of each type of tank pad and the possible detrimental effects on cathodic protection are still under discussion in the literature as well as in the industry. You can see and you can find worldwide several challenges. For example, in API 651 revision 1997, next slide please. In revision 1997, it is written in a paragraph in case of concrete slab type of tank pad. It said due to numerous complex factors that can affect the corrosion of a tank bottom underside in the presence of concrete, prediction of the propensity of corrosion in this case is extremely difficult. Thus, please click on the page. Thus, care should be observed with tanks on concrete pads since cathodic protection most likely will not help reduce any corrosion that might occur. Please click on the page. But in the new revision, in 2014 revision of API 651, it is written like this: due to numerous complex factors that can affect the corrosion of a tank bottom underside in the presence of concrete, prediction of the propensity of corrosion in this case is extremely difficult. Thus, care should be observed with tanks on concrete pads since cathodic protection may be ineffective in this case. Consideration should be given to keep the surface of the concrete tank pad and steel bottom plate free of contaminants during construction, and it is more conservative rather than the previous revision of the standard. It shows that still it is under discussion, and it's not a general consensus here worldwide about the type of tank pad and its effects on cathodic protection. Next slide please. For example, in regards to the sand pad type or clean sand pad type, in API revision 1997, it's only a small paragraph about clean sand. It's just described in a paragraph. But in revision 2014, it's about 3 pages about clean sand pad, and it's written in the second paragraph. You can see in this slide, these are suggested guidelines or considerations for the construction of above ground storage tank bottom sand pad, non-oiled, that were developed from practice represented by industry experience. It again shows that there is still challenges and there is still improvement in the efficiencies and effects of the type of tank pad on corrosion protection of underside of tank bottoms. Next slide please. After all, you can see in these photos, in some slides, I have prepared some photos of the corrosion of the soil side corrosion of storage tanks. Here you can see severe corrosion. In this picture you can see a space between the bottom plate and the tank pad. You can see the brown area is a tank foundation, for example, soil foundation. It's the last layer of the foundation that is in contact with the bottom plates. But you see a space or a gap between the bottom plate and the cushion of the tank bottom, and this space shows that the cathodic protection cannot be efficient here, because cathodic protection needs an electrolyte, and it needs full contact of the surface to be protected with the environment or the electrolyte, that is soil or tank cushion material. And again, another problem or another challenge with cathodic protection is that the annular plate around the storage tank does not have a full contact with the ring wall. So there is a gap again here, and it makes a severe problem, corrosion problem here, due to the intrusion of water, for example, rain, or sweating of the tank body, and moisture intrude underside the tank from these areas. In API technical report 654, which is first published on May 2019, API provides a technical report about how to seal the perimeter of the tank in order to prevent the intrusion of water and moisture underside the tank. And in API technical report 655, API published a report about vapor phase corrosion inhibitors usage for soil side corrosion control of the storage tanks. Next slide, please. Now I am going to describe a little about vapor phase corrosion inhibitors. Corrosion inhibitor is a chemical compound that, if added in small concentrations to an environment like an electrolyte, it mitigates corrosion. Corrosion inhibitors are categorized in different ways or different aspects. Neutralizers, scavengers, and film formers are some. They can also be categorized according to the mechanism they act to retard corrosion. They can be categorized according to the mechanism they act, to the composition of the chemical compound. They can be categorized with their application. They can be categorized with their toxicity, for example. Okay, next slide, please. Here you can see a type of categorization that they are categorized into interface corrosion inhibitors and environmental conditioners. Corrosion inhibitors may react with the metal electrolyte interface and interrupt chemical reaction that causes corrosion. A group of corrosion inhibitors reacts with the environment and decreases corrosivity of the environment. So they are called environmental conditioners, such as oxygen scavengers, which removes oxygen from the electrolyte, or biocides, which removes microbiologically induced corrosion, or neutralizers, and so on. Interface inhibitors may be in liquid form, which is in turn categorized into other types, or be in vapor phase, which is our topic here. Next slide, please. Vapor phase corrosion inhibitors, or volatile corrosion inhibitors, or VCIs, are chemical compounds with relatively high saturated vapor pressure, and therefore volatilize at atmospheric pressure and then condense onto the metal surface and form a protective layer in molecular scale, and then acts as a corrosion inhibitor. VCI products are available. Please click on the page, and next slide please. VCI products are available in the market in different forms and different shapes, including in powder form, in liquid form, in the form of spray cans, and different types of products are available in the market. Next slide, please. Yeah, volatilizes, deposits, and acts as a corrosion inhibitor. You can see the applications of VCIs here in the industry. VCIs now has a wide range of applications in electronics, electrical engineering, as you see in packaging, in automotive industry, in machinery. It has been widely used during the recent years. And okay, next please. And in storage and maintenance, and also in military applications, and in oil and gas industry. Next please. These are the applications of VCI, or vapor phase corrosion inhibitors. In oil and gas industry, VCIs also are widely used, for example, for corrosion under insulation, for wet layup, dry layup, hydrostatic tests. And in case of above ground storage tanks, as you see here, VCIs have been successful in combating soil side corrosion. When they are injected here, you can see, when they are injected into the tank foundation, yes, you see VCI, because it is volatile, it vaporizes and fill the space under the tank bottom and acts as a corrosion inhibitor, making a monomolecular layer underside of the tank bottom plates. Next slide, please. VCI can be applied for corrosion control of the tank bottom plates in different stages. It can be applied during construction of the tanks, it can be applied during the operation of the tank, and also it can be applied during maintenance, for example during the inspection of the tank and emptying the tank for the inspection and the repair, for example. It can be applied. Different approaches are used to inject and apply VCI for soil side corrosion control. Next slide, please. During construction, when you have a new tank and you are installing or constructing a new tank, you can use VCI pouches or VCI bags that are VCI powders inside a special paper. You can use these pouches in the foundation, as you see in the left photo. The pouches are installed on the, for example, geotextile and under the tank. And after that, after the making the layers, I mean sand layers and the compaction of the layers. Next slide, please. In order to monitor and in order to inject VCI in the future, a special piping system, next please, piping system can be installed in order to inject the slurry type of VCI in the future, for example every 5 years or something. Next slide, please. During for a storage tank under operation or in operation, we can use VCI through injection and drilling the tank ring and injection of the VCI slurry into the tank foundation beside the tank bottom plate and fill up the foundation space with VCI. Next slide, please. As you see here, from around the tank, you can use a vacuum drilling machine and install some tubes in order to inject the VCI slurry. Okay, next slide, please. When the tank is empty for repair and maintenance or periodic inspection, you can use VCI powders by fogging or injecting the powders underside the tank bottom by drilling the bottom plate, which is calculated every special spaces with a special diameter. You make holes on the tank bottom and then fog or inject the powder underside the tank bottom. As I showed before, there is a gap between annular plate and the ring wall, and as long as VCIs are volatile in a sense, they may drain out from the underside of the tank. Next slide, please. In order to block its drainage, a sealing system should be installed, and a special viscoelastic UV resistant tape should be applied around the perimeter of the tank to completely cover the annular plate and the ring wall. And this application will complete the application of VCI and keep the VCI material enclosed under the tank bottom. And this application is very useful and powerful to combat, and it has a successful history during the recent years in the tank farm areas and for storage tank sites in order to combat the soil side corrosion. And I hope you have used my presentation well. Okay, thank you listening to my presentation. Any question,
thank you,
please
sir.
leave a message.
Thank you, sir. Any question for Reza Labbaf, sir?